Continuing on, if I get to problem C, this is an angle. That's always what it is. I'm taking the sine of an angle, and I know that's a ratio. That is, in a right triangle, that is the opposite over the hypotenuse. I'll go on the side and I say, well, look, if I call theta to be the inverse tangent of 4, that means I must have had the tan of theta equal 4 over 1. Since it's positive, well, the beauty of this, if you start with an inverse trig function, all inverse trig functions are positive in quadrant 1. No need to worry much about it. Opposite over adjacent, that makes it the square root of 17, and sine is the opposite over the hypotenuse. There it is, everybody's happy. And if I move on to the next set of problems, this is also an angle. Oops, wrong key. So if I call this angle theta, I'm really looking for the tangent of this angle theta. Well, I know what that is. That's a ratio again. That is the opposite over the adjacent. I'll go on the side. If I let theta equal the inverse cosine of negative 1/5, that means I must have had the cosine of theta equal negative 1/5. Well, which quadrant am I in? Inverse cosine is negative in quadrant 2 or 3, but an inverse cosine can only be in quadrant 1 or 2, so I must be in quadrant 2. Adjacent over hypotenuse, of course that's negative. This will be the square root of 25 minus 1, which is 24. And it's positive in this quadrant, so that's what? That's 2 radical 6. And tangent is the opposite over the adjacent. And there we are. And again, I'm playing with all different combinations you can think of. This is theta. I'm looking for the sine of this angle theta. So I'm looking for a ratio of the opposite over the hypotenuse. On the side, I let theta equal the inverse tangent of negative 4/3. That means tan of theta must have been negative 4/3. Tangent is negative in 2 quadrants, quadrant 2 and 4. But the fact that I started the problem with an inverse, since I can't be in these quadrants, I must be in quadrant 4. There's theta. Opposite over adjacent. We know the y is negative. That's a 5. And the sine of that would be the opposite over the hypotenuse. And there it is. And if I take the sine of an inverse, they undo each other as long as that's in the domain and that's allowed. You could redo what I just did on this, but the inverse sine of a sine and the sine of the inverse sine, as long as the domain matches, they undo each other. We know that from before, because we know that f composite, its inverse, operating on x is x. So those undo each other, provided this is in the domain of the function. Last few problems. I'm looking for an angle. My answer is an angle. This is the inverse sine. Now, this is what we learned in both chapter 6 and 5. This is the triangle. 30, 1, 2, radical 3. What is the sine of 60 degrees? So reference angle is 60 degrees. Sine of 60 degrees is radical 3 over 2. Where's 5 pi over 3? 5 pi over 3 is in quadrant 4. Meaning it's negative. And since I'm looking for an angle, and I know the reference angle is pi over 3. I already established that. Since the inverse sine is negative, wouldn't that be simply negative pi over 3? I can never start an inverse sine and get an answer that is bigger than pi over 2, because that will exceed the first quadrant and that wouldn't be 1 to 1 anymore. And that's really the main confusion. Here, I'm looking for an angle. My answer is going to be an angle. So I'm looking for the inverse tangent, and let's see how this works. Reference angle is pi over 4. Very good. So if I keep in mind my answer is either pi over 4 or negative pi over 4 for an inverse tangent, I'm in very good shape. Well, let's see. What does that depend on? Is this positive or negative? If this value is positive, my answer is pi over 4 because I'm in quadrant 1. And if this value is negative, my answer is negative pi over 4 for both tangent and tangent inverse and sine inverse. Well, I know this is a 1. 5 pi over 4 and we know this is positive. Since that's positive, my answer is my reference angle, which is pi over 4. This is an angle. My answer is an angle, and that's the notation for an angle. I know the reference angle is pi over 6. So let me keep this in mind. My answer is either pi over 6 or my answer is negative pi over 6. That's all there is to it. And how is that? Well, this is the inverse sine. If this is positive, there's my answer. If this is negative, there's my answer. If I keep that in mind, then this inverse would fall into place. Well, I know that pi over 6 is 30 degrees. Sine is the opposite, it's 1/2. And where's 5 pi over 6? And in this quadrant, isn't sine positive? Since it's positive, my answer is pi over 6. So inverse sine, inverse tangent, my answer is either the reference angle or minus that, one of the two. Inverse cosine, my answer is either the reference angle or whatever that angle is in the second quadrant. How about this problem? Okay, that's not working. Well, I just noticed I didn't do an inverse cosine. Oh boy. Okay, give me a sec. Okay. I changed K to match what we need. So again, I'm finding now the sine. The sine is a ratio. This says the inverse cosine of -1. Where is that? That's a special angle. Inverse cosine is -1 at pi. And what's the sine of pi? Well, the sine of pi is a 0. How about here? My answer is an angle. So I'm looking for the inverse cosine of what? Well, I know the reference angle is pi over 4. I'm going to show you how it works. I have a reference angle of pi over 4. For inverse cosine, my answer is either pi over 4 or in the second quadrant 3 pi over 4, depending whether this is positive or negative. Well, this is radical 2 over 2. Where's 5 pi over 4? Right there. In this quadrant, sine is negative, so my answer is going to be what? Reference angle of pi over 4, but I'm in quadrant 1. Only inverse cosine have that. The answer is 3 pi over 4. And if I look at the last, it's also a ratio, right? I'm looking for the sine of this angle theta, and that's going to be an actual ratio. And let me see where that is. So where is this? This is asking that if you call this theta, tan of theta equal negative radical 3. What is my angle, or reference angle I should say? My reference angle is tangent equal radical 3, 60 degrees, or pi over 3, right? Except inverse tangent is negative pi over 3. Alright, well, what's the sine of negative pi over 3? I know the value, the sine of 60 degrees is the adjacent over the hypotenuse. And since I am in this quadrant, I know sine is negative. And that's pretty much it for this section.